Okay, today we're going to talk about systems of equations, and we're going to define it first. So a system of equations is a set of two or more equations. It's that simple. Okay, there we go. So if you have a word problem and it gives you a situation where you need to write two separate equations, that is a system. Oftentimes systems are, can't make my equal sign there, are written above one another, like this, and sometimes they will have a little bracket in front of them. Again, it can be two or more equations, so it may be 3 equations, it may be 4 equations. They will all relate to the same situation. All right? Now, a solution to a system is the ordered pair that makes both or makes all equations in the system true. Okay? Now, let's think about what that would look like. So on a graph, the solution is the point where the graphs intersect each other. All right? So now let's think about this. A point on a graph is going to be an ordered pair, an xy value, right? So let's come down here and draw an xy coordinate plane. Here's line 1. Here's line 2. This point right here where they intersect is the solution to that equation. Okay? Now we're going to focus on where there is one solution as we talk through the graph table and equations, and then we'll talk about if there's always one solution or if there are other options. Okay? So next we are going to look at a table. The solution on a table happens when there is a common ordered pair in both equations. Okay? So again, let's look at an example. We have 2 tables, and in one table we have points -1, 5, 0, 4, 1, 2, and 2, 3. And in the next table we have -2, 5, -1, 4, 0, 3, and 1, 2. We are looking for where there is a ordered pair in common. So -1, 5, -1, 4, that one doesn't work. 0, 4, 0, 3, that doesn't work. 1, 2, 1, 2. That is common in both. So here, the ordered pair 1, 2 is the solution. Okay? Now, we've looked at graphs and tables. Let's look at the equation. If we are looking at 2 equations, and we want to know, is an ordered pair a solution to both of those equations? An ordered pair is a solution to a system if it makes both equations true. Now, let's look at this. If I give you, let's see, is 5, 12 a solution to the system y equals, I'm sorry, that's a y, not a 4, y equals 10.5 plus 0.3x, and y equals 6 plus 1.2x. Okay, we have a system because we have two equations. What we're going to do to find out if this is a solution is we are going to substitute. Okay, so I am going to take my y value and plug it in here. 10.5 plus 0.3, and I'm going to take my x value and plug it in here. Now, at this point, I'm going to go ahead and just work the problem. On this side of the equation, I'm going to simplify. I've got 10.5 plus 0.3 times 5 is 1.5, and 10.5 plus 1.5 is 12. Well, 12 is what I've got on this side, so I'm going to go ahead and bring that down. 12 does equal 12. This is a true statement. Okay, so far so good. But remember, both equations must be true, so I have to do it for the second equation also. So I'm going to take the y and substitute in for 12 equals 6 plus 1.2 and plug in the 5 for the x. Now again, we are going to simplify this side of the equation. So we have 6 plus 1.2 times 5 gives us a whole number 6, and 6 plus 6 is 12. Well, when we look over here on the left side, 12 is what we have on that side of the equation, and 12 equals 12 is a true statement. Since both are true, 512 is a solution. Okay, I made a mess of my O there. There we go. Okay. Now let's take a look at how many solutions a system may have. Okay, your system is going to have one solution if the lines intersect in exactly one point. Okay, I shouldn't abbreviate like that, point. So when we look at our graph, and I am doing all of these by graph, so that's x and y. If our first line goes through here and our second line goes through here, these two lines intersect at exactly one point. It's the only point they share, so there is one solution. Okay. Now, an infinite number of solutions happens if your equations or graph have the same slope and the same y-intercept. Okay, so here we have an example. This is our x and our y. If I have my first line, and I'm going to make it really thick, and then my second line is actually the same line. Okay, you see that they share this point, they shared this point, they shared this point, they shared this point, because those points on both lines are just ordered pairs, but they are lying on both of them at the same time. So that is an infinite number of solutions. Okay. Now, no solutions is when the lines are parallel or they have the same slope but different y-intercepts. So we have our x and our y-axis. We have one line. We have our second line. These two lines are never going to intersect. The fact that they're never intersecting means that there is never going to be a point in here or anywhere in either direction where the lines touch each other. So therefore, there are no solutions. Okay? All right. Hope that helps get you started.